Hey folks, Thomas here. Welcome back to Mears Lab. In today's episode, I'd like to show you this vacuum tube guitar amplifier I've been working on. I wanted an amp that had lots of gain and lots of volume and a big full sound, so I thought, well, why don't I try to make a JCM800? And that's exactly what we've got right here, folks. I made a JCM800, but I also kind of wanted to make it a little unique, so I thought, what if I put the EQ section from a Fender amp into a JCM800? So that's exactly what I did. I've got a Fender tone stack inside of this amp instead of a Marshall style EQ. There's also a tube rectified power supply, and this amp has 6 V6s in the output section instead of EL34s. So it doesn't have as much output power, and it has a different tone that's going to be a bit closer to what a Fender Deluxe would sound like. I just finished working on the amplifier, and I haven't really fine-tuned everything yet, but it's still sounding pretty good as it is, so I wanted to make a video capturing the state of the amplifier right now, and then maybe later on we'll do some other mods to it and some changes and see what else we can do to this amp. I guess since it's sort of half a JCM800 and half of a Fender Deluxe, I would call this a JCM800 Deluxe maybe? I'm not really decided on a name yet. Let me know in the comments what you think it should be called. Here's a closer look at the top of the amplifier. This is the power transformer right here. It says 21BR17 on it. I don't know anything about this power transformer, honestly. It came out of a old radio, you know, like one of those stand-up ones with the big wooden cabinets from a really long time ago. It's almost like probably 100 years old. Yeah, I got a couple of those a few years ago, and I harvested them like crazy for parts and got a whole bunch of transformers and speakers and tubes out of them, and then repurposed the cabinets for other things. Anyhow, that's where I got that power transformer from. There's a 5Y3 rectifier tube here, which is sort of unique because this being a JCM800 style amp, normally they would have a solid state rectifier. So I think it's kind of neat that this amp has a tube rectifier inside of it. That's much more closer to like a Fender style amplifier. Here's the audio output transformer. This is a Hammond 1750PA transformer, and I think that's supposed to be from a Marshall amplifier actually. It's 18 watts, 70 to 15 or 70 hertz to 15 kilohertz, and the primary impedance is 8400 ohms, and then you've got 8 and 4 ohm outputs on it, and there's a 16 output tap as well too. And for this amp I just have the 8 ohm output wired up, but you could potentially put a switch on the amplifier. I did that with another one I made a while ago, and then you can switch the output impedance on it, which is kind of cool. The output tubes for this amp are 6 V6s, so those would be like the output tubes that are in a, say for instance, a Fender Deluxe. This one is made in England, and this one is a Sylvania tube that I don't know where it's made or much more else about it. They look kind of neat, and I think that they're about the same age. And when I put them on my tube tester, they tested about the same, so they're pretty close as far as a master pair goes. So they were great candidates to use for the output section on this amp. There's 3 12AX7 tubes here. This is the first one, V1, and that is definitely an old Mullard tube. I found that in an old reel-to-reel. Actually, I think I harvested that reel-to-reel for parts. I think that's where I got that tube from. I think I got a bunch of transformers out of it as well too, and some motors and stuff like that too. I think I even got some speakers out of that one. This is some random Fender tube that I think came from probably like a Hot Rod Deluxe or a DeVille or something like that. It's probably at least a couple of decades old. And then this one back there that's a Sylvania 12AX7, almost like a new old stock tube, that one. I pulled that out of a box. It came in a lot of tubes that I got a long time ago, and there's a whole bunch of brand new old stock tubes in it, and that's one of them right there. And that's the phase inverter tube right there. So that's V1 and V2, and that would be V3 right there. So this first one is the first tube in the preamp section. This would be the second tube right here, and then this third one in the back, that would be the phase inverter tube right there. And once again, all three of them are 12AX7s. Having a look at the front of the amp, here's our input right here. Pretty standard stuff. It's got a 1 meg input impedance like most other amplifiers. That works great for pretty much any kind of electric guitar pickup. Gain knob and bass and treble. There's no mid-range knob on this. It's sort of just preset for around the middle position. I usually just set the mids pretty much flat most of the time when I'm playing anyways, so I didn't even bother putting a mid-range control on this amplifier. And then there's our master volume control right there. It's a pretty loud amp. I haven't measured the output wattage of it yet, but here at home, I can't really play it much up past a quarter of the way without risking upsetting my neighbors. So yeah, I'm pretty pleased with the output power of the amplifier so far. There's a pilot light right there. I 3D printed this Mears Lab logo a while ago and made that for the amplifier. And then we just got the power and standby switches over here. And the switches just came from my local Princess Auto, actually. And for your own projects, you want to make sure that you use really nice heavy-duty switches that are rated for mains voltage, like these ones are right here. Okay, let's turn the amp around and have a look at the back of it. Not much to see back here. There's our output. I haven't put any labels or anything, and I didn't even really put any labels on the front of it. I just sort of scribbled on it with a Sharpie. I'd like to make it look a lot nicer and put some better looking labels on it, but since this is more or less just an experimental prototype amp, I'm not too worried about making it look too pretty, you know. It's more or less just needs to be functional. I'm pretty much just going to use this at home, really. There's our standard 3-prong power cable. Although there's no fuse, you can see on the back of the amp here, there is a fuse on the inside of it. I think I put a 2 amp fuse inside of this amp. It would sort of be a pain in the butt to have to change because you'd have to take the bottom off the amp. But at the time, I didn't have a chassis mounted fuse holder, so I just used one of those inline sort of ones. Well, I should mention the box of this project is a Hammond project box, and you can get these from DigiKey or Next Gen Guitar. That's a place I like to order a lot of parts from here up in Canada. And these boxes, they're not too expensive. You can get them in steel or you can get them in aluminum, and they're really nice and easy to work with. And I really enjoy using these boxes. They just come, they're not pre-drilled or anything like that. You have to drill your own holes, but they're really well made and they're really easy to work with. So I really like these. Well, I think I covered pretty much everything about the outside of the amplifier. Next, let's crack it open and have a look at the inside of the amp. Here's a look at the inside of the amplifier. I wanted to wire this up as simply as I possibly could, so I decided not to use any circuit boards or turret boards or anything like that for this build. Everything is just, I guess, point-to-point wired in this. So let's take a quick walk through the different sections of the amplifier, and then we'll have a closer look at those various sections. So right down here in the bottom right corner, that would be the power transformer, and then the audio output transformers down over there, just out of sight on the other side of the chassis. Over here we have the power and the standby switches, and that's our pilot light right there. And there's our audio input, and there's our audio output that goes to the speaker jack right over there. So looking at the potentiometers here, this is the gain pot, that's the bass pot, treble, and the volume pot right there. And over here we have, that's the very first preamp tube, which is a 12AX7. The second preamp tube, which is also a 12AX7. And the third 12AX7, which is a phase inverter tube right there. And then over here for the power tubes, there's a pair of them in push-pull. And these are 6V6s actually in this amp instead of like EL34s or something like that. I wanted to kind of make like a Fender Marshall hybrid sort of amplifier. And one of my favorite Fender amplifiers is the Deluxe Reverb, and it uses 6V6s, so there we go. That's why I decided to go with those. And they just happen to work really well with the transformer that I had on hand for the output, and that sort of stuff as well too. So it all just kind of came together there. And then down here, I'm not sure if you can see that very well or not, but there's a 5Y3 rectifier in this. And normally I just go with a solid state rectifier, but this time I had that 5Y3 tube hanging around, and this actually it came from the amp that I got this power transformer from, and so I thought, well, why not use that instead of the solid state route and see what kind of effect that has on the sound. Yeah, and speaking of this power transformer, yeah, I pulled that out of an old radio, and I got some tubes out of it as well too, including this rectifier tube here, and I love doing that sort of thing. It's a great way to find big, large transformers is in those old wooden stand-up radios. You can usually pick those up for free or pretty close to free on like Facebook Marketplace or Kijiji or whatever, and then you can usually harvest some transformers and sometimes even speakers and other stuff like that out of them as well too. Okay, let's have a closer look at the individual sections of the amplifier now. We've got our input right here, and there's a 1 meg grid leak resistor right there, and there's a, what did I go with? I think I put a 47K grid stopper resistor in there. Changing that from 68K to this whatever I put in there, 47K I think it is. It's not going to have a huge effect on the tone of the amplifier, and I didn't really change the value for any particular reason other than I don't think I had a 68K on hand at the time. But anyhow, yeah, so that's what's going on there. Then you can see on this 12AX7 tube socket, pin 1 is over here, and it goes 1, 2, 3, 4, 5, 6, 7, 8, and then 9 is right over there on the back right side. Okay, so we come in on pin 7 right here, and pin 8 would be our cathode, which is 1K I put in there, which the schematic I have says it should be a 2.7K. However, like a lot of my builds, I just kind of tossed a 1K in there for the cathode resistor, and I think I might just keep it like that, because compared to the schematic with a much higher resistor value, I think that this is gonna, I think it should give me more gain because it's a lower value. I'm not entirely sure about that, but I might change that out and put that 2.7K in, but I'm pretty happy with the sound of the amplifier right now, so I also might just leave that in there. Anyhow, yeah, that's something I might swap out at some point. Yeah, then signal comes out of our plate right here. Through this is I think it's a 0.022. Yeah, it is. Yeah, 0.022 cap right here, and then it comes up through the gain knob, and you can see here's the 470K resistor, and there is a 470 picofarad cap that goes across it as well too, and connected the input there, and then we have a 470 picofarad, or is that the 1 nano? What's that one? Oh yeah, this is supposed to be a 1 nanofarad, but I didn't have that, so I put in like a 0.82 nanofarad or something like that, 820 picofarad, whatever it is. It's an 822 cap. This amp replicates if you're going into the high gain channel, so you get that extra tube gain stage in the amplifier, because I really wanted a high gain amplifier. Come out of the wiper from that pot, go down this shielded wire right here that I used. This was just in here from the original build when I started this amp like years ago, because this amp, yeah, I started it years ago and it just sat on the shelf for years in sort of a semi-working state, and then I recently put it on the bench because I really wanted to get it going. I don't think that this is really necessary at this point of the amp to put the shielded wire in, but it certainly doesn't hurt. Pretty much any instance where you're using a shielded signal cable, you just attach the shield at one end, of course. You don't want to attach it at both ends, because then you'll create a ground loop and probably add more noise to your circuit. Anyhow, yeah. So on the second side of this first tube, yeah, we come in on pin 2. Pin 1 is the plate, and pin 3 is the cathode. And the cathode over here is a 10K. And that's just like the schematic, which is really sort of weird, right? This is really out of place to see a really high value resistor like that for a cathode, especially in a preamp stage. But that's part of the way that Marshall clips their waveform in such a way that you get like the characteristic Marshall sort of sound. And it's really important to have that higher value resistor in the cathode stage here. Something I want to experiment with is changing this value though and lowering it to maybe like half of that, like 4.7K, something like that. Maybe even going more extreme than that and going down to like 2K or something around that value. Because this, if you lower the value of this resistor, apparently that will increase the amount of distortion in the amplifier, so you get even more gain out of it. So that's something I want to tinker around with right there. And yeah, I just haven't done it yet. So I wanted to stay pretty close to the schematic for now. And then I'll get into changing some things. My basic theory is just get the amp up and running and make sure it's working well, and then go in there and do all the nitty gritty sort of fine tuning and stuff after that. Okay, yeah, so there's our 10K cathode. And oh yeah, before I move on here, sorry, I want to go back to the cathode from the first stage here. I don't actually have a bypass cap on that cathode at the plate or across the resistor, and that's something I'm planning on adding in there. I just once again, I just haven't done it yet. I don't often put a cathode bypass cap. I don't often use them anywhere in the amps that I make, but sometimes I do, depending on how much gain I want into the amp or how much I want to change the tone. My ears aren't really finely tuned to what the sonic effect is of adding a cap in and like changing the value is just yet. So that's one of the reasons I don't put caps in, because I'm trying to tune my ear to what all these subtle changes that an amplifier do. And I find if I just keep it really simple, then it's easier to get a basic understanding. And then as I make changes and implement different value changes and things in the circuit, as I move along in my work, I get a broader sort of understanding of some of those things, like what adding a cap in and what changing the value of that cap is going to have on the tone before I do it, and then so I can sort of predict the results. It takes a while, but it's okay. It's also kind of cool to know what you need to put in an amp and what you don't need to put in an amp. And a lot of the time I like to just go with the bare essentials. Just put the absolute least amount of stuff in the amp that you possibly need, and then sort of add some more stuff in there as necessary to build it up. Sort of like, I see it like a foundation on a house. You know, you build a really solid foundation and then you put all your stuff on top of it or whatever, you know. Anyhow, yeah, I call that meat and potatoes, and the fancy stuff is like the gravy over the top, you know. So I just stick to the meat and potatoes here. Yeah, okay, anyways, moving on. Yeah, so V1B, we come out of the plate, and yeah, I think that's just like a 100K resistor that feeds that plate, same as the first plate too. And yeah, then we come out of that through this .022 cap, and you'll see this is where things get kind of hairy with my wiring right here. You can see that, you know, normally you would have like a terminal tie strip, and you would solder all your components to that, or a circuit board, and then you'd have like wires that go right over to it, and everything's really nice and neat and tidy. I don't know, I just didn't really bother with that this time. I just kind of just soldered all the things together. Just made like a sort of a bridge. And the thing is here, it's really solid, it's in there, it does wiggle around, but that's only if I'm really pushing on it, you know. Like, this thing is not going to budge ever in the amplifier. Even if it were to get dropped really hard, this is never going to move around. It just looks a little messy, you know. But there is one thing I think that's kind of cool about it, is that by doing it this way, you're really having like kind of the shortest signal path that you can possibly get out of it, you know. And that's something I really like, is you're eliminating wires and components. And, you know, like, look, like there's the pin right there. It goes directly into this cap. There's a little bit of lead exposed right there, but then right through the resistor, boom, right into that pin on the other tube socket. There's no extra wires and stuff like that. So although having it sort of floating around in the air, it gives you the idea that it's going to pick up a lot of like stray capacitance in the amplifier, and it might, you know, have some negative effects on the tone. But Who's to say what is actually a negative effect on the tone in terms of capacitance out there anyways? You know, even if components are laid out on a fancy circuit board or on a terminal tie strip, there's going to be stray capacitance everywhere anyways. So who's to say that if they're over there in a nice tidy little line, or if they're just standing up here, like, yeah, sure, this might have different capacitance, but is it better or worse? I don't know. I'm not the one to say that. But I can tell you for one that this does work and it does sound really good. So there's that too. Probably one of the main concerns of having things just sort of flying around in the air, all willy-nilly like this, is that it gets a little dangerous, you know, because there's like some exposed stuff going on right here, and if you were to touch that, you get a shock. But then again, you know, like on the other side of the amplifier, there's like 120 volts of AC that you could theoretically touch if you tried hard enough, you know. And there's all kinds of areas around the amp where there's exposed lethal voltages. So the general consensus is you just got to be really careful inside of the amplifier anyways. Unless you're really interested in electronics and enthusiastic about doing things the safest way you possibly can, then I wouldn't really advise cracking open an amplifier and sticking your fingers in there anyways, you know. So I think for anybody that's genuinely interested in electronics, working like this is just fine and dandy because you're aware of what the risks are, and you know, as long as you're taking your time and you're careful, then you can kind of work with those risks. And because there's always a risk involved, you know, and you just gotta choose your battle, sort of a thing, you know. Okay, now we come into the input over here, and same idea as this other tube socket. Pin 1 is here and pin 9 is on the back side, so it kind of goes around this way, like 1, 2, 3, 4, 5, 6, 7, 8, 9, where 9's in the back and 1's in the front. Yeah, so right here, first cathode, it's supposed to be 820 ohm on the schematic, but I don't think I had that, so I just put a 1K in there as usual, you know. If in doubt, put a 1K in. That's kind of my theory. No, not seriously, I'm just joking around. But yeah, sometimes that kind of gets the job done. Anyhow, yeah, there's a 1K plate resistor in here for that stage, and that's pretty simple gain stage right there, nothing really too special going on. But what happens after that is pretty cool, because the plate of that gain stage, you'll see there's no bypass cap that comes after that, or AC coupling cap, depending on how you want to look at it. Yeah, I actually tied those together just with the extra lead from the resistor there. That plate goes directly into the grid of the next gain stage, and that's because one of the coolest things about the JCM800, the EQ in this is actually fed from the cathode of this stage. The EQ happens much later in the circuit compared to like a Fender amplifier, and that's really, really cool. It's called a cathode follower. The signal comes directly off that plate and hits the grid. So the reason why that's pretty crazy in an amplifier to see that is because normally you wouldn't want to have any DC voltage on a grid, but here you're getting like the full plate DC voltage right here. So it's probably, I don't know, it's probably something like 160 or 200 volts or something like that hitting the grid. So normally it'd be like, whoa, that thing's gonna explode. However, there's something really cool happening with that gain stage, and this would be, so V2B we're talking about right now, the cathode follower stage right before the EQ. Okay, so the plate on this stage right here has no plate resistor. It's connected directly to the B+ supply, and instead they use a 100K resistor on the cathode, which is so super duper cool. So if we check out, where is the cathode? Right here. There it is right there. I'm not sure if you can see that resistor or not, but there's a 100K resistor there. So that just keeps the voltages close together for the cathode and the grid, and that's what keeps the tube from blowing up, because it's not having a high grid voltage that's going to ruin the tube. It's having, what would the wording be for that, a potential difference between the grid and the cathode. It's having too big of a voltage difference between the grid and the cathode. That would be the issue. But this keeps them closer together, and is kind of essential for this being a cathode follower, because the signal that we're going to take from this gain stage is not from the plate where we would normally get it. We're actually getting it from the cathode. That's where the signal is coming from, and that's what this white wire is right here. So that coming from the cathode right there, and then that goes up to our EQ. Okay, so here's where the signal comes up here, and this is a pretty standard EQ tone stack, except in the way that it is totally not. It's basically a JCM800 with a Fender tone stack and a Fender power section. Yeah, so kind of like a hybrid between a JCM800 and a Deluxe reverb without reverb, I guess. So yeah, a JCM800 Deluxe. Is that maybe? Yeah, I guess maybe that's what I'd call it, a JCM800 Deluxe. There you go. Yeah, so here's the difference. So on the Marshall schematic, like the components are laid out basically the same way, but they use different values for a Fender and a Marshall. And that gives a resultingly different sound. And I'm not going to go into the subjective nature of EQ and stuff. I'm just going to talk about the objective values of the circuit, because you can kind of derive your own conclusions from that. On this amplifier, I'm hitting, this is like two 100 picofarad caps that are in parallel, so that gives us 200 picofarads. I didn't have a 250, which is I think the normal value that you would see on a Deluxe, but 200 is pretty close. So I went with that, and there's our treble potentiometer right there, which is 250K, and then which is pretty similar. I think that the Marshall uses a 220K pot there, and yeah, that's pretty close anyways. Then the slope resistor is a 100K, just like a standard, pretty much any Fender amplifier out there. And that's pretty different from the Marshall, which uses a 33K there normally. So a much more steeper value. And that's really going to slope the EQ much more towards the mids and the treble sort of a situation. Yeah, I think that's how it works, at least anyways. Correct me in the comments if I'm wrong about that. And then for caps, I think what's happening here is there's a 0.1 and 0.047. Is that right? Yeah, that's exactly right. Yeah. So that's what I used, which is pretty standard values for a Fender amp. And a Marshall would be like a 0.022 for both of these, actually. And then they'd use a 33K slope resistor. And Marshall would also use a 1 meg, but not me in this amp. This is a 250K, just like a standard Fender amplifier. And then I use a 10K resistor for that mid-range sort of scoop thingamajig right there. And I could tinker around with that, and that would change like the mid-range sort of frequency response of the amp, give it more or less of a scoop. But I think 10K is a pretty sort of like nominal value to use, because usually you see a 20 or a 22 or a 25K pot used in a mid-range. So, you know, 10K is about half of that. I suppose I could get really exact and use like a 12K, but I'm not so concerned about getting things just like bang right on. Yeah, so there's the EQ section. Essentially, it's basically, like I said, a Fender Deluxe reverb EQ section, or pretty much the EQ from pretty much any Fender amp. And overall on the sound, what I will say is it really gives the amp a lot of clarity. It's a much more clean sounding amp. So it's like a high gain clean amp. You can get quite a bit of distortion out of it as it is right now, but it sounds like a Fender amp. It's like a lot cleaner, you know? You can just turn down the treble a bit and warm up the amp if you want, you know, or turn the bass up or whatever. But even if you just leave the EQ knob set flat, it still sounds good. It's just really crisp and clear. It's not really bright or like harsh or anything. It's just really crisp and clear. And personally, I like that because I like to use humbuckers, and it helps. I just feel like it to cut through and not sound muddy, or like it's got a blanket over it. I'm always looking for really crisp treble, not bright or harsh, but crisp. I really want to hear like the really chimey part of the tone when I'm playing, and at least have access to that so that I can turn it down. But I found that in some amps I'd tried before, no matter what, you can never get a good clean sound out of them because they always sound like they're too dull or too harsh, and you can just never find the sweet spot. But I found that the first time I plugged into a Fender Deluxe reverb, like, that was it. Like, that was the closest I'd ever heard to like that really crisp, clear sound that wasn't too bright. So that's sort of what I'm going after all the time, is like a clear sound, not a bright sound. How you actually get a super clean and clear sound, that's not something I'm really qualified to speak on. You know, I have a lot of theories and things, but I don't have really a lot of scientific evidence to back that up. But yeah, this is how I build amps. That's sort of what I'm going for, and hopefully everything I do here sort of contributes to that clear tone sound I'm going for. After signal leaves the EQ section, it goes through volume pot right here, and then that goes out here. I used another shielded cable for this. Once again, that was just left over from the previous build. It certainly helps, but once again, I'm not sure that it's actually necessary for this stage in the amp. However, there is a lot of gain that's happening before this, so I thought, well, it certainly isn't going to really hurt, so I might as well add it in. So yeah, so I use the shielded cable down there, and then go through a 0.022 cap right here, and that goes into the phase inverter right here. So this is a pretty standard long tail pair phase inverter. I use the exact same values in this amp that are in the 2204 JCM800. So there's two 1 meg grid leak resistors in here, and for the cathode resistor there's a 470. Yeah, it's a 470. And then our tail resistor is a 10k. Yeah, that's right, 10k. And then after that tail resistor, this would be like the negative feedback resistor. It's a pretty high value here compared to a Fender amp. Actually, it's a 4.7k. Although in this amplifier there is no negative feedback. I have not added negative feedback into this amp, but I did still put the resistor in there so that if I wanted to, I could later on. However, with the change in the power tube section, you know, like the original 2204 uses EL34s and this amp has 6V6s in it, I wanted to just get the amp up and running before I started messing around with negative feedback values and stuff like that. So I might still get into that, but I don't know, I might just leave it as is. I prefer an amp without a negative feedback loop. Okay, here we go into that subjective tone stuff. Sure, like negative feedback loop, it does tighten up the amp and it gives it a bit more headroom, but I feel like a lot of that's subjective. And, you know, I'm building an amp for me to play through the way I want it to sound. And I like the sound, and especially like the feel of an amp without a negative feedback loop, because I feel like it's a lot more looser and more, here comes all those words. It's like more organic, you know, it's like, it's more dynamic and it's more touch responsive and blah blah blah, all that sort of stuff. But there, you know, as silly as those words are and it sounds, you know, like there is some credence to it. Like, you know, like tone is a real thing, you know, and I can hear and I can feel the difference when I'm playing my guitar. And yeah, I prefer the sound of an amp without the negative feedback loop. And also I'm just sort of curious about that right now too, because a lot of amps, most amps do have negative feedback loops. So I want to get more accustomed to the sound of an amp without one, because I haven't really heard or played through that nearly as much as the other way. I'm not sure how well that's turning out on the camera. Hopefully you can see it okay. But I did another one of those sort of really hacky wiring jobs here. This one's even hackier than the one I did over here, where I just sort of like wrapped all the components around each other and then just soldered them together. I mean, they're really solid. Like, they wiggle around a little bit, but when you really break it down, you know, it's actually pretty solid. Like, there's 3 points of contact. There's a ground right here, and then there's the 2 grid leak resistors. And I kept the mounting points for these resistors that are closer to the chassis, that are actually soldered to the sockets in the chassis. I kept the lead lengths on those pretty short, so they're quite rigid. and but they still have a little bit of give, which I think is a good thing. I think that every component should have a little bit of give and a little bit of wiggle room, just to allow for, you know, like as the amp is moving around, and sort of in the same idea that like buildings are meant to sort of move around and sway in the wind a little bit. I think that it's better for the components to have a little bit of wiggle room, just because then you're okay as you're moving the amp around and it gets jostled around in your car or on stage or whatever, you know? Yeah, so it's never going to move in a way that's going to be damaging to something else, you know? Pretty standard stuff. All the values are pretty much the same here. Nothing really much more interesting to look there. Yeah, then our signal comes out of there through a couple of, what did I use there? 0.022 caps I used from the plates of the phase inverter. And I want to mention here that I just used 100k resistors for both sides of the phase inverter. Normally you'd use 82k on one side of it and 100k on the other side, but I thought, oh, let's get all wild here, and I'll use a 100k on both sides, and we'll see what that sounds like. So far, honestly, the overall effect that it has on the tone is like minimal, I would say. But if I were to put a oscilloscope on it and check it out, I might see some inconsistencies on there. Like maybe one side of the phase inverter is a bit stronger than the other side. But you know, like I'm building like a high gain guitar 2 amp here, you know. I'm not making an amp that's meant for, you know, like listening to classical music, you know. Like I'm gonna rock with this amplifier. I don't care if it distorts a little bit more here or there, you know. I kind of want it to do that. Well, before we go over there, let's just have a closer look at this crazy phase inverter I've got going on here. Look at that. So here's the power section. We've got a pair of 6V6s. These are running in push-pull. And on the plates, I think there's about 330 volts, something like that. And the screen grids, maybe 305 or 310 volts. And then I think then the cathode, it's measuring around 18 volts, something like that. And I've got what's in here right now, 220 ohm cathode resistor in here that's just shared by both of the cathodes. Yeah, I went with just a really simple cathode bias, sort of an idea here. And I haven't measured what the output power of the amplifier is. I have no idea what the output wattage is. I know it sounds pretty loud, and it's probably running around 15 watts, maybe not even that, maybe only 12 watts or something like that. But it's pretty ripping loud, and it's got quite a bit of gain, and I'm pretty happy with it right now the way it is. However, that's definitely something I could tinker around with later on, and I could change that to like the stock sort of JCM800 biasing method instead, and probably get quite a lot more power out of the circuit. But they are only 6V6s, and so say like a deluxe reverb is really only running 22, well, not only, it's actually getting 22 watts out of 6V6s, which is pretty crazy, because to get that amount of output power out of them, you really have to run them way outside of their maximum sort of ratings. But hey, you know, like it works, and it made one of the greatest sounding amps of all time. But anyways, let's move on here. Yeah, so we got some 470 ohm resistors for the screen grids, 220k grid leak resistors, and I mean, there's not really much more to look at, really, you know. It's a little hairy, right? It gets a little hairy in this section right here. This is where I get all the B plus lines to run out to the 12X7s. This I'm not proud of. This is pretty hairy right here. I just connected all the wires right to the one of the leads from the filter cap for that section, and yeah, it's pretty hairy, but you know what, it gets the job done, and it's really solid. Like, it's not gonna budge anywhere. It's fine and dandy, and there's a ground post right here that cap is mounted to, so it's nice and solid, you know, and the wires are all solid, and they're not gonna touch anything else or whatever, you know. It just looks a little hairy, but you know, the aesthetic matches the rest of the amp pretty well, at least. Okay, and here's a shot from the other side, so you can see this tube socket here, and you can see there's a couple other filter supply caps. And you can see the first dropping resistor right there. So as the B plus comes out of the 5Y3 rectifier, goes through the standby switch, and then it goes through a 2K dropping resistor that goes to the screen grids. And I feel like I could raise that value even and probably go to like 4.7K. When I first built the amp, I had a 1K value in here, and that made the screen grids basically the same voltage as the plates. However, I wanted to drop that a little bit just to try and increase the life of the 6V6s, because I don't know just how good these 6V6s are. They're pretty old, and I pulled these out of some old radio at some point in time. And although I've tested them and they work fine on my tube tester, you know, I just don't want to drive them right into the ground. I think that they're kind of cool. Like one of them is, I think one of them's a Mullard. Actually, one of the preamp tubes is definitely an old Mullard. And so I just kind of want to be careful with them. I don't want to push the screen grids too hard on them. Yeah, so I put a 2K in there for that. And then the other dropping resistor is a 10K. And I only use 2 dropping resistors. And there's just 3 filter supply caps in here. So there's, what else is in there to look at? Not really too much more to look at in there, really. That's basically the whole inside of the amplifier. I've been thinking about what kind of changes I might like to do to the amplifier from here, and I think what I'm going to do next is increase the amount of gain I can get out of the amp so I can get more distortion. That's always fun. And I am kind of curious what a Marshall style EQ would sound like in the amp instead of the Fender style one. But you know, I'm undecided on whether I should change that or not. So maybe let me know what you think in the comments, whether I should keep the Fender style EQ in this or put a Marshall EQ in it instead. See what that would sound like. I'm not really sure. Another thing I need to do is fine tune the circuit. Generally, after I finish an amp, I fire it up and just play with it and enjoy it as it is and sort of just get accustomed to the sound of it and how it works and that sort of stuff for the first maybe couple of days or couple of weeks. And I usually just sort of leave it for a bit, and then I'll come back to it and I'll do some fine tuning of the bias and the cathode resistor values, and I might add some bypass caps onto the cathode resistors as well too in certain areas of the amp. Maybe fine-tune the phase inverter a little bit, just stuff like that. But I don't always really like going in and doing that fine-tuning of an amp afterwards. Sometimes I feel like I'm getting too into the nitty-gritty, and yeah, I don't like to get too obsessive over the sound and stuff like that. Sometimes I just like to leave it as is and just be like, you know, it turned out it's sounding pretty good and it hasn't caught on fire yet, so let's go. But I'm not a big fan of just leaving things willy-nilly either, so I don't know. I try to find the common ground between those two theories, and we'll see what the future holds for this amplifier. Alright folks, well that brings us to the end of today's video. I really appreciate you all watching, and if you enjoyed the video, then don't forget you can hit the like button, and you can also subscribe to the Mears Lab channel for more videos just like this. Thanks again, and I'll see you next time.